All right, so for this example, we're using the vectors from above, and we are going to use our tip to tail method, okay, using the tip to tail method that we discussed above in order to draw out our vectors, and then we're going to find the magnitude and the direction angle of the resultant vector. Okay, so just for convenience, let me go ahead and copy this down so we can have it in front of us. Okay, let's throw that there so we have it in front of us. Okay, so the first thing we're going to do is we are going to add W plus V. Okay, so W plus V. So here is our W. And here is our V. Okay, so remember using the tip to tail method, basically we start with our vector W and then attach the vector V to the tip of W, and the resultant vector will connect the two. Now when you're drawing these out, in this context, it really doesn't matter where you place it on your grid. You can just kind of place it wherever you think will be easy to fit them in, okay? So I'm going to go ahead and copy over my vector W. And if you're just sketching these out, basically just think about the units. So W, we can see, is going 1, 2, 3, 4, 5 units to the right. So make sure when you draw it out, it's going 1, 2, 3, 4, 5 units to the right. Okay, so that's our vector W. Okay, so then at the tip of W, we're going to attach the tail of V. So copying over my V. Oops. Okay, and V, you can see is going 1, 2, 3, 4 units down, -4. Okay, so make sure that this guy is going 4 units down. Okay, so that's my V here. Okay, so then the resultant vector starts at the tail of W and goes to the tip of V. Okay, so that right there is our resultant vector, W plus V. Okay. All right. So once you get it sketched out, then you can also find the magnitude and the direction angle of that vector. Okay. So for our magnitude, we're just looking for the length of the vector. That's just going to be Pythagorean's theorem. So we said we were going 1, 2, 3, 4, 5 units right and 4 units down. All right, so our magnitude of W plus V, just using Pythagorean's theorem, be the square root of 5 squared plus -4 squared, or would come out to the square root of 41. Okay. All right, and then our direction angle, I'm going to measure our angle theta from the x-axis. Okay, so we can use our tangent function again. Tangent is opposite over adjacent. So this was 4 down, 5 right. So we would have tangent of theta is equal to -4 over 5, where theta would be the inverse tangent of -4 over 5. And if we plug that into our calculators, our theta would be -38.66 degrees. Okay, so that's going to be our final answer. Okay, let's go ahead and find z plus 2v next. Okay, so z plus 2v. Go ahead and move this down. Okay, so let's see. If we're starting with our vector z, think about our z over here. Z is going 1, 2, 3, 4, 5 units right, 3 units up. So again, it doesn't really matter for these where you start on your paper. Just kind of pick a spot and start there. We'll go ahead and start here. And our Z we said was going 5 units right, 3 units up. There would be my vector Z. Okay. Okay, and then we're adding to it 2v. So 2v basically just means instead of going 1, 2, 3, 4 units down, we're going to go 8 units down. It's just twice the length of v. So starting at the tip of z, we're going to go 1, 2, 3, 4, 5, 6, 7, 8 units down. And that will be the vector 2v. All right, so then our resultant vector goes from the tail of z to the tip of 2v, and that is our answer. Okay. All right, I'm going to leave the magnitude and the direction angle for you guys to try on your own. Okay, I think you can get that figured out. Okay. All right. C, we have v minus z. So this is the first time we're subtracting vectors. Okay, so v minus z, we're going to start with our vector v. That's this guy right here again, which we said was 4 units down. So start with our vector v. 1, 2, 3, 4 units down. Okay, and then we're subtracting the vector z. So originally, z went 5 units right and 3 units up. Now when we're subtracting a vector, we still are using the tip to tail method. So we start at the tip of v, but the subtraction basically just means that the direction is opposite. So instead of going 5 units right, we're going to go 5 units left. And instead of going 3 units up, we're going to go 3 units down. Okay, so starting at the tip of V, I'm going to go 5 units to the right and 3 units down. So that would be my vector right there, negative z. Okay, so it still has the same magnitude as the original z, but the opposite direction. Okay, so then our resultant vector again goes from the tail of v to the tip of z. Okay, all right. Go ahead and find magnitude and direction angle on this one with you guys again. So magnitude, remember we're always thinking of the length of our vector. Okay, so you want to think about building out your little right triangle. So we're going 1, 2, 3, 4, 5 units to the left, and 1, 2, 3, 4, 5, 6, 7 units down. So the magnitude of this vector would be, just using Pythagorean theorem, square root of 5 squared plus 7 squared. Okay, so that would come up to the square root of 74. Okay, now for our direction angle, we're going to start by finding this little angle right here. I'm going to go ahead and call that alpha for now. Okay, now that's not actually going to be our final angle though, because angles, of course, are measured from the positive x-axis. Find a different color. Okay, so theta is the angle that we're actually looking for, the angle measured counterclockwise from the positive x-axis. So we're going to start by finding the angle that falls within our right triangle and then using that to figure out what our actual direction angle is. Okay, so start off by using your tangent. So we would have tangent of alpha to begin with is opposite over adjacent. So alpha would be the inverse tangent of 7 over 5. And plugging that into our calculator, we get 54.46 degrees. Okay, so that's our reference angle. 54.46 degrees is our reference angle. Okay, but our actual answer has to be this angle theta. So since we're in quadrant 3, we're just 54.46 degrees past the 180 degree mark. So our theta is just going to be 54.46 degrees plus 180. So if we add 180 to that, we get 234.46 degrees. Okay. So sometimes you have to be a little bit careful when you're finding your direction angle to make sure that you're actually looking within the right quadrant. So when you use that inverse tangent, you're going to get your reference angle, but make sure that you're actually pointing in the right direction. So you might have to add 180, you might have to subtract 180, you might have to be a little bit creative with it in order to make sure you're going in the right place. Okay, so the last one here, we're looking at z plus w minus u. Okay, all right, so again, using our tip to tail method to add and subtract these vectors together. All right, so starting off with our vector z, which again was 5 right, 3 up. So just pick a spot to start. We're going 1, 2, 3, 4, 5 right, and 3 up. That's our vector z. Okay, then we're adding on to it the vector w. So w goes 1, 2, 3, 4, 5 units to the right. So 1, 2, 3, 4, 5 units right is our w. That lined up right. Okay, that's our w. Then we're subtracting u. Okay, so u goes 4 units right and 2 units down, which means negative u is going to go 4 units left and 2 units up. So 4 left, 2 up from the tip of w. Okay, a different color. Okay, so that is negative u. All right, and then our answer, the resultant vector, goes from the tail of z to the tip of negative u. So that is our answer, z plus w minus u. Okay. All right, and again, I'll leave it for you guys to find your magnitude and direction angle, but basically you would just think about drawing in your little right triangle and finding your angle theta right here. Okay. Okay, guys, so I'm going to end this video here, and in the next video, we're going to start looking at a different way that we can represent vectors algebraically instead of geometrically.